Today I'm going to talk about piecewise functions. The key to understanding piecewise defined functions is in recognizing the parts of the name, piece. Basically, a piece-defined function consists of pieces of different functions. We are going to start by making piecewise functions out of linear functions. So I want to be sure that you guys still know how to write the equation of a line. Now, remember, slope-intercept form looks like this. Y equals mx plus b, where m is the slope and b is the y-intercept. So if you look at your first line, the y-intercept here is 6, so b is equal to 6, and the slope I can find by finding a nice point that where my line intersects exactly at a grid mark and just counting. So I can count slope. Remember, slope is rise over run. So from this point I go up 2 and right 1. So my slope is up 2 and right 1. My slope is 2. So when I write the equation of that line, it's y equals 2x plus 6. Now in my next line, my y-intercept is 1. And my slope, again, I can count. So if I start here, my rise is that I go down 1 and I go right 1. So my slope is down 1, negative, and right 1, positive. So my slope is -1. So as you count, you're either, if you go down, it's a negative rise. If you go right, it's a positive run. So down on my graph is negative, up on my graph is positive. Right on my graph is positive, left on my graph is negative. And I really can count any direction. So in this particular case, my rise was -1 and my run was +1, but I could have gone up and to the left as well, where my rise would have been +1 and my run would have been -1. So you can see that that would come out to be the same thing. So you can count either direction. So in this particular case, the equation of my line is y equals -x plus 1. So that's how you write the equation of a line in slope-intercept form. Next, I want you to look at the next graphs on your notes, and I want you to take a minute and see if you can see any similarities between the top graphs and the bottom ones. What's the same and what's different? So pause your video and take a minute to think about that. Okay, so when I look at this, I see pieces that are the exact same. So if I were to look, I can see that this line is part of this line. I can see that this line is part of this line. That's where the word piecewise comes from. So as we write the equation of our function, we're going to use parts from here and a part from there. The key is that it's different on different parts of my domain. So if I write my function, I'm going to write it as f of x equals, and then I'm going to put a bracket there because I'm going to put two different equations based upon the domain where that function's active. So if you look at the pink part of this graph comes from my top graph up there. So I'm going to have 2x plus 6 on that part of my domain. And then I have to specify where it's 2x plus 6. I'm going to make this a little larger so that I can fit it in. And you can see that my domain for this part of my graph goes from -6 to -1, and it includes the -6 point, and it includes the -1. So I'm going to write this like this. This is for x less than or equal to -1 and less than or equal to -6. I don't like how close that is. Let's see if I can move it. I think I'll just erase it and move it over. Make this a little smaller. Okay, so this is where x is between -6 and -1. And you'll notice I used less than or equal to signs there because these are closed circles. Now, the next part of my function comes from the part that's green here, which happens to be the same equation as the one we wrote previously over here. So this part of my equation would be f of x equals -x plus 1. And I would then again need to specify my domain. So this goes from -1, and it does not include -1, and it goes on forever to infinity because I have this arrow there. So I would specify my part of the domain where this is active as x is greater than -1. Notice that I did not include equals, so it's not where x is equal to 1 at all. It's where x is -1. Now, the next graph is different than the first graph. However, the equations within my function are the same. What differs is the domain. So we're going to write the name of that function. I don't know what I'll call it. Maybe I'll call it g of x. So g of x is equal to, and again I need to put the bracket there, and this part, let's put the highlighting in again. Oops, don't like. That comes from my pink line above, and the other side comes from my green line above. The difference is the domain. So f of x and g of x will look identical, except that I will specify different parts of the domain where the pink and the green part of my graph are active. So let's see, g of x will be equal to 2x plus 6, and that is going to be when x is between -6 and -1. And notice it does not include the -6, and it does not include the -1 since those are open circles. So that's x between -6 and -1, and I did not put an equality as part of my inequality. Now, the next part of my function is minus x plus 1, and you'll notice that is where x is greater than or equal to -1. So our functions look identical, but the domain on them, on each of the parts, is different. Now I want you to take a look at these functions. They're all graphed here, and I want you to match the name of the function with the graph. Notice they all look nearly identical, except the domains are different on the different pieces. Pause your video, and when you're ready to see the answer, press play again. Okay, here are the results. Take a minute, check your work. But again, it's all based upon what the ranges are. So I put the numbers that went along with the functions. If you got something wrong, press pause, figure out what happened. Remember, an open circle does not have an equality with part of it. So you'll notice in this picture here, it's number 2. I have 2 open circles there, and I have a closed circle on the 1, and it goes off to infinity. Okay. Now I would like to look at the graphs, and I would like to write the equation of each function. So with this one, we're going to actually have to figure out the equation that go with the pieces. So let's see, I'm going to make this a little big. We're going to do f of x together. So I need to look at my pieces separately, and I'm going to first specify the different parts of the domain that need to be changed. So let's see, this one would be f of x. Again, we're writing the equation for this top left graph. And I have 2 pieces in here. I have a piece where x is less than -1, and I have a piece where x is greater than -1, and it's not greater than or equal to, it's just greater than -1. You know that because there are open circles on each. So the challenge here sometimes is that as you look at this, you can't easily discern where the y-intercept would be for this. But generally speaking, you can count and figure out what it should be. So if you notice here, your rise is 2, your run is 1. So in looking at that, the slope of that line would be up 2, right 1, or 2. And then if you look at it closer, if I keep going up 2 and right 1, my y-intercept would be 4. So B would be 4. And I can write my equation now. It would be 2x plus 4. Now, as I look at the right-hand side, I can easily see what my y-intercept is there. My y-intercept is 5, so that's kind of nice. And then I have to figure out what the slope is. So from this crosses as a nice grid mark. So my rise would be -1, my run would be 2. So I wrote slope 5, that should have been a B, hold on. So my y-intercept there is 5, and then, again, my rise is -1, my run is 2. So my slope here would be -1/2. So now I can write the equation of that part of my graph. It would be -1/2 x plus 5. And there you have the equation of that function. Now I'd like you to write the equations of g, h, and p. Press pause on your video when you're ready to see the answers. Press play again. Pay really close attention to what the domains are for each piece. Okay, so here are the answers. If you had some difficulty with it, you might want to ask a neighbor. Notice that on the third graph and the fourth graph, I have this section here that's constant. You write an equation of a line that's constant as y equals whatever that y value is. No matter where I look along that part of it, y is equal to 1. So that's where that came from. And then everything between h and p are identical except the domains. That changes. Okay, the next thing I'd like to do is graph some of these things. So I am going to work on graphing the first one, F, and if you have trouble figuring out where to draw your graph, sometimes it's helpful to put a little dashed line between the different parts of the domain. I don't always do it, but it can't hurt. So I can see that my function is changing at +2. So up until +2, up until right before I hit 2, it will be this, use this equation. And after that, as soon as it's equal to 2, and after, I will use this part of the equation. So let's see, I'm going to draw myself a little dashed line just to remind myself that this happens at 2. It's not going to be solid because that's not part of my graph. It's just a reminder. Now, remember, these are lines. So as soon as you can find 2 points on the line, you can connect them, and that is the line you're trying to draw. Sometimes it works out really nicely with the y-intercept. You'll notice on the second part of my equation, it doesn't because this part of the domain does not contain the y-intercept. Let's work on the left side first, and then we'll work on the right side, and I'll talk it through. So I know my y-intercept from this top part is 3. So I'm going to put a point there. I also know that the slope is -1/2, so I can use my slope to find another point. So I can write my slope in one of 2 ways. It can be -1 over +2, or it can be +1 over -2. Now remember, we want to stay on the left side of this green line. We're not going to cross it no matter what, because this is the only part of my graph. I only use this equation on the left side of my graph. So let's see. I'll try going down 1 and right 2. if I do that, down 1, right 2, that's fine. I land here, and that line will be there up until I hit 2. So I can draw an open circle at that spot. And then, once I have that drawn, I have 2 points, so I can now use it to create my line. So I'm going to draw it in. Like so, and you'll notice that is when x is less than 2, which means that it will go on with an arrow that way. Now, the right side of my equation is going to use this part of my function. So I'd like to know what my y value is when x is exactly 2, so I'm going to figure that out. F of 2 is going to equal 2 over 3 times 2 minus 2. So that's 4/3 minus 2, or 4/3 minus 6/3, which is negative 2/3. So unfortunately, it doesn't come out to be very pretty, but I can get a good idea of where that is. So it's below the x-axis, 2/3 below it. So, and remember, it is a closed circle. Ooh, I put it in the wrong spot. So it's going to be right here. Then I can use my slope to find my next point. My slope is 2/3. So from this point, I'm going to go up 2 and right 3. So I should land right about there. I'll put another point. Up 2, right 3, right there. And then I'm going to draw my line. And you can see that it looks as if I cross at exactly 3, 0. And sometimes if I don't like the numbers I'm getting from the points that I plug in, I try to pick something that'll come out nice. If I multiply anything by 2/3, I'm going to get a whole number so long as what I'm multiplying by is a multiple of 3. So I would likely have done that and done f of 3 and said, okay, that's 2/3 times 3 minus 2. That would be 2 minus 2, or 0. So that's something else that can be done as well. So now we have this nice picture. I'd like to say what the domain is overall. So we have to think about condensing our graph onto my x-axis and seeing what points are covered. In this particular case, it would be negative infinity to infinity. Everything's covered. As I look at my range, the smallest y value I'll ever get would be negative 2/3, and it includes that. And then the largest y value I get, it will go off to infinity. It looks as if this is an open circle, but it's not, because I have this part of my line that will cast that shadow on the y-axis. So it goes from negative 2/3 off to infinity. Now, that's that one. Let's look at number 2, or g of x. So now I have 3 pieces. I have a piece that's defined between negative 5 and 1. I'm going to draw myself some lines in here again, between negative 5, I don't want to forget, and positive 1. And I have a value at exactly x equals 1. And then I have a different function when it's greater than 1. So I have my intervals marked here really well. So I'm going to look at the first part of my equation, and you'll notice that the y-intercept is 3. I'm going to plot that since it's in that part of my domain. Oh, I think I'd like a different color. Let's use pink. And then I can use my slope to draw the rest of it. Or I could simply plug in an x value and plot that point. So my slope is 1. So that means I'm going to rise 1 and go to the right 1. So here I'll rise 1 and go right 1. Now notice at that spot it needs to be an empty circle because it does not include when x is equal to 1. So I'll draw myself an open circle there. I can also think about my slope as going down 1, and left 1. I can do that, or I can now simply draw that part of my line. Notice at -5, my y value should be -2. So I'm going to plot that as well. And that is a closed circle, since it does include when my domain is -5. Now, another way I could have done it besides using the slope is just said, well, I'm graphing a line. I'm going to find a point on this part of my domain and a point on this part of my domain, and then I'm going to connect them. And that absolutely would work as well. Okay, so now I'm going to draw in that line, connecting those. Okay. Now, the next thing I need to do is I need to look at the next part of my domain, and in this case, when x is 1, y is -1, so I'm going to plot that. Oops, wrong spot. There we go. That's why I draw the green lines. Now the next part is when x is greater than 1. So I'm going to find out what y would be if it was exactly equal to 1 and draw an open circle there. So if x is 1 on here, I would get y is -2. So I'm going to have an open circle there. And then I can really find any other point that I'd like by just plugging in a value here. Or I could use the slope. The slope is -2, which means down 2, right 2. So that works as well. If I go down to right 2, I have a point right there. And then you'll notice that this is as long as x is greater than 1, which means it's going to go on forever to infinity. So I'll draw that. So now the next step is to determine what the domain is. The domain starts at -5. Remember, it's all the x values, and it goes off to infinity. I will always, if I condense my graph onto that x-axis, the entire x-axis is covered. It goes off to infinity. Now my range, I have to look at and think of condensing my graph onto the y-axis. Every part of my y is going to be covered until I get to 4, and that will be an open circle there. So that goes from -infinity up to 4, curved bracket. Okay, press pause on your video feed, and when you're ready to see the answers on these two, press play again. For the answers, if you got something else, take a minute and check your work. I'm checking mine as I think about it. It's very easy to make a mistake. Okay, of course, if you're just finding out where you want to put those open circles. Now, the last thing that we're going to do today is evaluate piecewise functions at various x values. So I want you to think about this. When you walk up to the restroom, there are 2 doors into which you must choose to enter. You cannot enter both doors at the same time. You have to pick one. The sign on the door qualifies you to enter into the correct door. Evaluating a piecewise defined function is much the same way. If you want to put an x value of 3 into a piecewise defined function to find its corresponding value of y, you have to look at the constraints. Those are the inequalities that I've been writing after each part of my function. In the function, to determine into which piece of the value of 3 must replace x. Now, how do I know what is the fundamental reason I cannot put x equals 3 into more than one piece of my function? And notice function is underlined. So I'm going to pause the video and think about that. Why can't you do that? When you're ready to hear the answer, press play again. It is because in order to be a function, each value of x can only have 1y. So each value of x should not enter the various pieces of your piecewise function other than once, except, okay, so I'm going to take a look at this. I'm going to do the first one with you, and then I'm going to give you a minute to do some work. So if you look at, to find f of -7, you first have to decide what part of the function you put it in. Now notice, it doesn't go in the first part, right, because it can't be equal to -7, and it doesn't go into the second part either. So in that case, it's undefined. Next part, if I look at f of -3, I notice it doesn't go into the first part of my equation, it goes into the second part. So that would be -2 times -3 plus 2, which would be 6 plus 2, or 8. Now I'd like you to pause your video feed to do the rest, and when you're ready for the answers, press play again. Okay, check your answers. Hopefully you got them right. If not, double check your work. I hope you now understand a little bit more about piecewise functions. I'd like you to do the assignment that's posted for you online. Have a great day.